Maintaining a clean, pleasant environment is a common aspiration for all of us who live on this planet Earth. But in today's world, various kinds of hazardous substances that pose a risk to our health and lives are generated in our pursuit for greater convenience. Air pollution and stained exterior walls of buildings caused by exhaust fumes, sick house syndrome induced by certain building materials, odors from pets, garbage, and cigarette smoke, as well as SARS, E. coli 0157H7, new strains of bird flu, and fungus caused by fungus-induced pulmonary aspergillosis. Our lives are increasingly at risk. In the hope of protecting people's health and keeping our buildings and precious living environment clean, Soma's photocatalytic PAL coat was developed. The principle of photocatalysis was first discovered in Japan, and subsequently the technology of photocatalysis was developed. Because of its significant potential, the technology is gaining attention as a key technology of the 21st century. So, what is photocatalysis? In 1967, Professor Fujishima of the University of Tokyo accidentally discovered the splitting of water into oxygen and hydrogen when titanium dioxide powder in water is irradiated with light. The discovery of photocatalysis, which is very much like photosynthesis by plants, was published in the British science journal Nature in 1972. It was called the Honda-Fujishima effect and attracted the world's attention. Photocatalysis is summarized as the mechanism by which chemical reaction of titanium dioxide is caused by light. Further research for utilizing photocatalysis' power of oxidation led to its commercialization. In 1999, Dr. Hiromichi Ichinose of Saga Ceramics Research Laboratory succeeded in the manufacture of water-soluble titanium dioxide. Saga Prefecture took out the patent for the titanium dioxide, which is harmless, safe, and exceptionally stable. In photocatalysis, when light energy from sunlight or fluorescent light, for example, is irradiated on titanium dioxide, a strong power of decomposition is generated on the surface of the titanium dioxide by its properties. By this reaction, various organic matters that come near the titanium dioxide are continuously decomposed until they become harmless. Photocatalysis' effect is almost permanent. Let us examine the principle. When light energy is irradiated on the surface of titanium dioxide, electrons are released. The released electrons bind with oxygen to become superoxide anion. Moreover, the surface of the titanium dioxide becomes positively charged and takes electrons from moisture in the air. The moisture that has lost electrons becomes hydroxyl radical. The superoxide anion and hydroxyl radicals, by their power of oxidation destruction, decompose organic compounds such as oils, unwanted bacteria, hazardous scientific gases, fungus, and offensive odors that cause staining, turn them into water or other harmless substances, and disperse them into the atmosphere. By utilizing these properties of titanium dioxide, Soma's PAL coat coating agent was commercialized. The PAL coat forms a thin layer of photocatalytic coat over a surface and provides the surface with photocatalytic functions. Besides its ability to decompose substances, another main feature of a photocatalysis is its hydrophilic nature. When a building surface or glass is photocatalytically coated, raindrops will form a thin, uniform layer of water over the surface and remove the dirt that is on the surface. This self-cleaning property is long-lasting and is made possible because of the photocatalysts' hydrophilic nature. Let us examine the effectiveness of the PAL coat with regard to decomposition and hydrophilic nature. Red ink is sprayed on white tile that has been coated with PAL coat. A coin is placed on the tile. When the tile is irradiated with light, it gradually returns to its original white color, and after several minutes, the ink is totally decomposed. If we remove the coin, the red ink remains over the part covered by the coin. We can clearly see that the ink has decomposed. Let us spray water over the glass. There are no water drops in the rectangular part in the middle. We can see the scenery outside clearly through the glass. The part with no water drops was coated with Palcoat. There are no water drops because, by Palcoat's affinity with water, they washed off the dirt and oils on the glass. This building, as it stands next to a highway, is stained considerably by automotive exhaust gas. One half of this exterior wall panel is coated with Palcoat. After more than 2 years, the coated part has no stains and has maintained its beautiful appearance. Because the effectiveness of coating is long-lasting, the difference becomes clearer as time goes by. Photocatalysis is also effective in cleaning the air. Therefore, a building coated with Palcoat is environmentally friendly. A coating of 1,000 square meters of the exterior surface of a building will apparently have the same effect in purifying the atmosphere as 50 poplar trees. Let us see how Palcoat is actually applied. As in the application of regular paint, Palcoat is applied mainly by spray gun or by roller or brush, depending on circumstances. The coating agent is water-soluble. It is harmless to man and animals and is eco-friendly. The painter does not need to wear a mask, and there is no need to cover parts of the building for protection. Palcoat can be applied to a variety of substrates. The Palcoat Group has been involved in the application of Palcoat in a wide range of fields. In the construction of JR Nishi-Funabashi Railway Station building, photocatalysis has been introduced into the design of the station building. Palcoat is used in the exterior walls and glass ceilings. Because of Palcoat's excellent track record and reliability, it is also used in the exterior walls and glass surfaces of JR Matsumoto Railway Station. In a food factory that must maintain the image of cleanliness, Palcoat was applied to the exterior walls. Palcoat is contributing to maintaining the clean, beautiful appearance of the factory. Palcoat is also used for the coating of exterior walls of stores and houses over a wide range of surface materials, including brick and tile. Moreover, its effectiveness is not limited to outdoors. Palcoat is used for deodorizing, disinfecting, and purifying the air inside cars, nursing homes, nursery centers, and hospitals. And it is used in fitness clubs. It is also used to prevent sick school and sick house syndromes that were covered widely in the media. It is also used in hospitals. Not only do we provide construction-related services, we also offer photocatalytic products such as sprays and towels, and products for artificial flowers and preserved flowers that purify the air with photocatalysis for the general consumer, to further promote our technology. Today, photocatalysis is applied in a wide range of industries and is accepted widely by the public. In March 2006, the Photocatalysis Industry Association of Japan was founded. With the Ministry of Economy, Trade and Industry backing, Palcoat and other photocatalytic technology are making remarkable progress. Palcoat carries the Society of Industrial Technology for Photocatalytic Articles (SITPA) mark, which is awarded to products that the association recommends and that are placed under proper quality management. We have also gained international certification for quality management systems. We strive to provide the highest quality products and services to our customers. Today, we face a crisis of global warming, deforestation, and other forms of environmental destruction. The Palcoat technology proposed by Soma Company contributes to creating an environment in which future generations can live with a sense of security.